In this video, I'm going to cover Wilcoxon test. Wilcoxon test is a non-parametric test, which is to remind you, it doesn't have to be from the normal distribution. There is no any requirement about distribution. It can be any distribution. And non-parametric test that can be used to determine whether two dependent samples were selected from the populations having the same distribution. That's the Wilcoxon-Sion rank test. So we have two dependent samples. To remind you what can be dependent, so some sample before intervention and after intervention, right? So they are dependent, obviously, and we are going to decide based on Wilcoxon-Sion rank test if these dependent samples were selected from the populations having the same distribution. Okay, unlike the Sion test, it considered the magnitude. Magnitude, just so you know, it's an absolute value, so you drop the negative sign and we use only positive. Absolute value or size or of any data. That makes the Wilcoxon-Sion rank test more powerful than just Sion test. What are our objectives here? We are going to learn how to use Wilcoxon-Sion test to determine whether two dependent samples are selected from population having same distribution. And second, we are going to find out how to use Wilcoxon rank sum test. It's going to be next video, the second one, to determine whether two independent samples are selected from population having same distribution. So Wilcoxon, let me see, Wilcoxon-Sion rank test we are going to explore, and Wilcoxon rank sum test we are going to explore. In one case, we are using dependent samples. In the case of rank sum test, we are using independent, but in both cases, we are going to check. In both cases, Wilcoxon test is going to identify if samples are selected from the same population having same distribution. Okay? So these ones, those are step by step. Okay, so I'm not going to read those. Me clean, we need to identify this is going to be alpha, level of significance, because I'm going to use all this on the practice, so just so you know. Okay, critical value I will represent. So let me start. You can stop it and write down what you need here. Okay, but I am moving to practicing problems so we can learn how to perform Wilcoxon-Sion rank test. Okay, here we go. A golf club manufacturer believes that golfers can lower their scores by using manufacturer's newly designed golf club. The score of 10 golfers, we have 10 golfers here, 1, 2, 3, from 1 to 10, while using the old design, this is the old design, and while using the new design, shown in this table, alpha is equal 0.05. Can you support the sport manufacturer's claim that golfers can lower their scores by using manufacturer's newly designed golf club? So they believe in golf clubs, and they believe that it can lower their scores. All right. So claim that can be lowering their scores, new design. Null is going to be do not lower, right? It's like equal to the old one. Okay. Since we have two-tailed test, equal, not equal, alpha is equal 0.05, and n is equal 9, because we have 10, right, golfers, but let me see, where is it? Let me find, here, number 5. Oops, I used white color, hold on. Okay, we have here 91, 91, so we don't count when difference is 0, so it's identical, which means no reaction, right? Since it's the same, no reaction, then we cannot, makes no sense to count it. Therefore, we have here 9 instead of 10. Make sense? At least it does make sense to me. Okay. So, principle is same. So we are going to find test statistics, critical value, and then compare and blah, blah, blah. So how we are going to get significant Wilcoxon rank test? First of all, to get critical value of this table, you can either search on the internet, Wilcoxon sign rank test, or just to take a picture from this one. So since we have total amount, we said we have 9, right? We eliminated 10 because there was no difference, correct? So we have 9, and we have one tail is 0.05. So for two tail, it's going to be 0.1 multiplied by 2, right? So we are getting for two tails 0.1, and therefore our critical value, it's going to be 8. Okay, we got our critical value. Now let's find our test statistics. So how we are going to do Wilcoxon sign rank test? This is all these scores from all design that you see previously in horizontal line. Now it's represented in the vertical position. So score all design and new design. Here it is. So what we're gonna do now, we're gonna get difference between old and new designs. Here is our difference. So we get here 6, 89 minus 83, 6, 84 minus 83, 1, and so on. Okay, all the way down. Okay, next. We are going to take, next step, we are going to take absolute value. That's a magnitude. Absolute value, which means all these negative signs, it's going to disappear. Here is disappearing, here is disappearing. Now, next we are going to rank them by order. What means ranks? From smallest, arrange this absolute value from smallest to highest number. Let's say arrange like 1, 2, 3, next if coming, let's say another 3, then coming 5, 7, 9, and so on. Whatever comes in the order. Okay, so and we are going to rank the following way. This is going to be 1, this is going to be 2. Here I am going to have 3, and since it's same 3, it's 3 and 3, so which means that since there are both of them 3, I'm going to get half of it, meet halfway, 2.5. So it's going to be 2.5, 2.5. Okay, and then this will be 4, this will be 5, this will be 6, and so on. So first one is number 1, first one, and then number 2 is coming. We have 2 of them, right? 1 and 2. That's why instead of 2 and 3, we took the average, 2.5, 2.5. Yes, 0 doesn't count because there is no difference. And then 3, we have 3, it's going to be 4 because after 3 comes 4. We just didn't write down 3 because we have 2 of them. We wrote down 2.5, 2.5, but we counted 3. Next is 4. And the fifth, number 4, absolute value, also looks like 2 of them. So instead of 5 and 6, we put 5.5, 5.5, 2 of them. So it's the same. The reason we are doing, so we would understand that there is more than one of same absolute value. Otherwise, if I put 5 and 6, then you will accept like two different numbers, right? Different absolute values. That's why. Okay. Now, let me clean this. And lastly, we are going to bring back the cyan. Okay. We are going to bring back the cyan here. The cyan rank. So which means here we had negative. So we bring back this negative. Here we have negative. We bring back this -4. What for do we need? Because then we are going to do cyan rank testing. Meaning I'm going to add sum of negative ranks, right? We have -2.5 and -4. It will be -6.5. The rest we're going to trust, 8 plus 1, 5.5, and blah, blah, blah. We are going to get how much? We are going to get 38.5, the cyan rank. And we are going to take the smallest one by absolute value, magnitude. We are taking magnitude. It's going to be positive 6.5. And positive 6.5 compared to our critical value that was 8, if you recall it. It was 8. Remember, our alpha was 0.05. Since we had two tail, we multiplied, we got 0.1. And with n amount was 9 total, minus total is 10, but we did -1 because 1 didn't give a difference between old and new design, so it became 9. So critical value, we got 8. And comparing to 6.5, our kind of test statistics is 6.5. 6.5 test statistics is less than our critical value. Therefore, we are going to reject null hypothesis. Write down. When critical value is greater than test statistics or test statistics less than critical value, we reject null hypothesis. Okay? So at 5% level of significance, there is enough, since our claim is at the same time, our claim is alternative one. Yes, it was alternative one. So if we reject null hypothesis, then we fail to reject alternative, right? And that's mean we are going, if we fail to reject, we are going to support, correct, our alternative hypothesis. Therefore, at 5% level, there is enough evidence to support the claim that golfers can lower their scores by using a newly designed club. So you can take a note that if test statistics is less than critical value, we reject null hypothesis. If test statistics is greater than critical value, then we fail to reject null hypothesis. And we dance from there. This depends on what the claim is, alternative or null hypothesis. Okay, rank sum. This one I will record in next video. So now I'm going to turn to assignments, record the assignments after this, okay?